So in this chapter, we are going to discuss about the haloalkanes and haloarenes. Okay. So before that, we have to know what are haloalkanes, right? Okay. So haloalkanes means in the name itself, it's clear that halo means halogen. So alkene means normal hydrocarbon. So haloalkanes means we can say the hydrocarbons they containing halogen atom. So normally we can say like the halogens or haloalkanes have the general formula Rx. Here R is the alkyl group or it may be some aryl group. X is the halogen. So they are generally called haloalkanes. So haloalkyls are of two mainly we can divide them into different classification. Before that we are moving to the introductory part. So here haloalkenes and aryl halides are formed when hydrogen atom in an aliphatic or aromatic hydrocarbons are substituted with halogen atom. Okay, so here normally I am having CH4 molecule means one carbon atom is surrounded by four hydrogen atom. So in this molecule, I am replacing one of the hydrogen atom with some halogen X. So X may be chlorine, bromine, iodine, any of the halogen. So that type of compound, now this become CH3. Suppose I am replacing with chlorine CH3Cl, right? So this compound, this is called chloroalkane, and commonly we can call it as alkyl halides. Means in from the hydrocarbon, the hydrogen is substituted by some halogen. So this hydrocarbon part may be some aryl group also. Suppose in a benzene ring, I'm replacing one hydrogen with halogen. So here CH is there. Here again CH means all the carbon atom have one hydrogen, right? So one of the hydrogen atom, I'm replacing this hydrogen with chlorine. Now they become the benzene ring that is connected to chlorine. So this is called aryl halide. Means this is an aromatic ring and halogen is connected to this ring, so they are aryl halides. Okay, so in an aliphatic, so aliphatic means normal chain like the CH3 CH3 CH2 any chain, or aromatic means this cyclic ring containing alternative double bond. So normally these groups, so this aryl group or the alkyl group, we can represent with R, and they have the general formula Rx. So in contrast to haloarenes, which include halogen atom connected to sp2 hybridized carbon. So we know that in the benzene ring, each carbon atom is sp2 hybridized form, right? So here in these particular haloarenes, the halogen atom is connected to sp2 hybridized carbon, because in benzene ring they are sp2 hybridized carbon atoms. But in normal haloalkanes, the carbon atoms are normal carbon, means they are not the sp2 hybridized carbon, they are simply sp3 hybridized carbon atom. So that is the difference between these haloalkanes and haloarenes. So there are a lot of hydrogen containing organic molecule, we know that, because many of the naturally obtaining molecules are organic molecule, and they are widely used for in daily life and industry. So they have many usage. Means in the organic chemistry, organic field, we can use it for the synthesis of many of the compounds. So they have very means variety of uses, very importance in pharmaceutical chemistry, then analytical chemistry, then other means the other field of chemistry like industrial chemistry. Okay, so they serve as both starting materials and solvents for variety of generally non-polar chemicals, as well as organic compound synthesis intermediates. So they can be used for the synthesis of many compounds, means they can be used as the starting material for many of the reactions. So they are the important thing regarding the haloalkanes. Okay, now the next one. So this is the introductory part regarding the haloalkanes. So the haloalkanes means we are moving to the reactions and everything we will discuss in this chapter. So here the one more thing, see, typhoid fever can be effectively treated with antibiotic chloramphenicol, which is manufactured by the microorganisms and contain chlorine. So the uses of haloalkanes means you can say these medical field, they have, means the haloalkanes have variety of uses in this medical field because of this thing. Here for a treatment of these type of typhoid fever. Okay, then goiter can be treated with the compounds which contain this iodine. So synthetic halogen chemicals such as halothane used for anesthetic during surgery, and chloroquine in used for, means in medicinal field they have lots of importance. So they are completely fluorinated substances are being explored as possible surgical blood substitutes. Means They have importance in medical field also. Okay, so next one, we are moving to the important parts of this chapter. That is the classification of haloalkanes. So the haloalkanes means we know they are the hydrocarbon. The hydrogen atom is substituted by the halogen atom, right? Now we are moving to the classification of this particular haloalkanes. So first one, the classification of halogen atom based on the number of halogen atom. So in a halogenoalkane, as I said before, the hydrogen atom is substituted by the halogen. So in a hydrocarbon, more than one halogen atoms may be there. Means more than one hydrogen atom may be substituted by the halogen atom, right? In some cases, only one hydrogen may be substituted by the halogen atom. Suppose I am taking an ethane molecule, CH3, and this here the one carbon is surrounded by three hydrogen, here one carbon surrounded by three hydrogen. So what I am doing here is, here I am replacing one of the hydrogen from this carbon with halogen. So this is a monohaloalkane. Now what I am doing is I am replacing two hydrogens from this carbon. So it will be CH, then two halogens will be there. So that is dihaloalkane. So we can, if you are replacing three hydrogen with halogens, it will be trihaloalkane. So based on the number of hydrogen atoms replaced by the halogen, we can classify the hydrocarbons into haloalkanes into mono, di, and trihaloalkanes. The same classification is there in case of haloarenes also. See here in this benzene ring, I'm replacing one hydrogen with the halogen, so they are monohaloarene. I'm replacing two means they are dihaloarene. Three means trihaloarene. Got it, right? So these compounds can be mainly classified into these type. Then what is polyhalogen? If more than two or three halogen atoms are there in this compound, they can be generally called as polyhalogen compounds. It may be tetrahaloalkane, pentahaloalkane. So commonly we can call it them as polyhalogen compounds. Okay, that is the first classification of haloalkanes. Next one, based on the carbon atom, based on the hybridization of the carbon atom, we can classify them again. So here first one, haloalkyl halides or haloalkanes. So this is the same thing that I discussed before. So here the alkyl halides are formed by the halogen atom bonded to the alkyl group. Then primary, here we can classify them into primary, secondary, and tertiary haloalkanes. What is this primary, secondary, and tertiary? Here the halogen atom connected carbon that is connected to only one carbon. They are called primary haloalkane. Now the halogen is connected to one carbon, that carbon is connected to two carbon, that is called secondary haloalkane. Now again halogen is connected to one carbon that is connected to three carbon, that is tertiary haloalkane. Now one example. Suppose here CH3 is there and this is one halogen. Here halogen is connected. Halogen is always connecting to one carbon. Then we have to check how many carbon atoms are attached to that carbon. So here you can see the halogen containing carbon is connected to only one carbon. So this compound is called primary haloalkane. Now what I am doing here is, and the CH3 is still there. Now one hydrogen I am changing to, I am replacing with one alkyl group. Then again one more here. Okay, first we will discuss about secondary, then we will move to tertiary. Okay, so next one, here hydrogen is still there and here is the halogen. Now you can see the halogen is connected to one carbon, that carbon is connected to two carbons. See, this is one carbon, this is another one, so they are called secondary haloalkane. Now one more thing, here the halogen is there which is connected to carbon, that carbon is connected to three carbon. See, it is not always CH3 group. See, I'm writing here CH2 CH3. Still this is tertiary, because here whatever it may be, this may be methyl group, ethyl group, whatever it may be, leave it. This halogen containing carbon is connected to how many carbon atom, that one we have to choose. Okay, suppose here halogen connected carbon that is connected to one CH3, one hydrogen, and here I am writing CH2 CH3. So here you can say this is not tertiary, because halogen connected carbon is connected directly connected to this carbon and this carbon. This carbon is not connected to the halogen containing carbon. This is a part of the alkyl group. So don't call it as tertiary. This is still secondary. This is also tertiary, because this is not quaternary or anything. No, one this carbon connected to one, two, three carbon. So this is tertiary haloalkane. So this is the classification. May other class type of classification in which the halogen connected carbon is connected to how many carbon? So primary, secondary, tertiary. Okay. Now the next classification here, the compounds containing. So the former one was the compounds containing sp2 carbon, right? Okay, so sp3 carbon. So again we are moving to the sp3 carbon itself. Sp2 we will discuss later. Okay, so again the carbon is the halogen connected carbon is still sp3 as before. See here also the halogen connected carbon is sp3 hybridized. Again in the next classification also the halogen connected carbon is sp3 hybridized. So they are allylic halides and benzylic halides. Okay, so allylic halides means they are formed when the halogen atom is bonded to the carbon atom which is next to the carbon-carbon double bond. That is allylic. See, here the halogen is connected to this carbon and this is connected to, see, these two carbon atoms are doubly bonded. So halogen containing carbon is adjacent to the double bonded carbon. That is called allylic halide. So this is another example. See, this halogen containing carbon is connected to double bonded carbon. Next one, benzylic. Benzylic means halogen atom is connected to sp3 again. Here this carbon is still sp3. Okay, but here that is connected to again sp3 and that is attached to the aromatic ring. See, halogen is not connected to the aromatic ring. Halogen is connected to one carbon, that is sp3 hybridized, and that carbon is connected to the aromatic ring, that is called benzylic halide. In allylic and benzylic, both the halogen is connected to still sp3 carbon, and that carbon is connected to a double bonded carbon or sp2 carbon. That is the difference. Okay, so the next classification we can say compound. So this is the classification in which the halogen is connected to sp3 carbon. Now the halogen is connected to sp2 carbon. Okay. So here, first one, that is vinylic halide. The halogen atom is connected to here sp2. This is directly, the halogen atom is directly connected to the sp2 carbon and the double bonded carbon. See this is a halogen. This is the double bond. So halogen is directly connected to the sp2 carbon. That is called vinylic halide. Now aryl halide means the halogen is connected to sp2 hybridized carbon atom of an aromatic ring. That is the difference. Here the halogen is, so this is not an aromatic ring. Aromatic ring means alternative double bonds should be there. Here alternative double bond is, this is cyclic compound only. But this is an aromatic ring. So halogen is connected to sp2 carbon. That sp2 carbon is a part of aromatic ring. And here the halogen is connected to sp2 carbon and that carbon is not the part of aromatic ring. Simply sp2 carbon. So this one may be there, this one may be there. So don't be confused about these two.